Welcome to our deep dive. And today we're going to be looking at material science and advanced manufacturing.
Yeah, it's an exciting field.
It is,
Where we're really kind of pushing the boundaries of what's possible.
yeah, blurring the lines a little bit between science fiction and reality.
Absolutely. And when we talk about material science and advanced manufacturing, we're really talking about, the stuff that makes up our world and how we're building things in a whole new way.
Yeah, and that's what's so cool about this topic is like we could be talking about anything. We
Right?
could
Yeah.
be talking about, airplanes. We
Okay.
could be talking about, tiny little microchips,
Healthcare.
healthcare. It all comes back to them.
All starts with the materials.
So let's just kind of start with a quick overview of the basics.
Yeah.
They're talking about materials like alloys, composites, even smart materials. Each has unique properties that kind of determine how it's going to be used.
Yeah, it's like you think about building a skyscraper. You're not going to build it out of rubber.
Right.
Right. It's about choosing the right material for the job and
Yeah.
understanding, the properties of these materials. So, high performance alloys, they can withstand the extreme conditions of a jet engine. Whereas, lightweight composites, that's what's making our cars more fuel efficient.
And, that's what's so fascinating to me is that, like you were saying, the materials are really what dictate how we can use something.
Absolutely.
Like we can come up with all these great ideas,
Mhm.
but if we don't have the materials to actually make them,
It's just an idea.
then it's just a thought experiment, really.
Right.
So it's like the materials kind of unlock the possibilities.
Exactly.
So, all right, so materials matter big time, but how do we actually go about turning those materials into products?
Right. Well, that's where advanced manufacturing comes in.
It's okay.
And this is where things get really interesting. We're talking about processes like 3D printing, where you're essentially building an object layer by layer from a digital design.
So it's like a really fancy glue gun.
It kind of is.
It's like a high-tech glue gun that can create these super complex shapes.
Things that, traditional manufacturing methods just couldn't even dream of.
I've even seen, companies that are 3D printing entire houses now,
It's incredible.
which just blows my mind.
And the great thing about 3D printing is that it's so efficient. You're only using the material that you need. So there's minimal waste. And we're seeing this technology being applied in so many different industries, from aerospace to healthcare. It's even changing the way we create prosthetics, custom prosthetics for individuals.
Yeah, that level of personalization,
It's a game changer.
especially in medicine. I mean, it's got to be incredible for people.
Absolutely. And it's not just 3D printing. Robotics and automation are transforming the factory floor as well.
Okay.
So robots are able to handle those tasks that are, dangerous or repetitive or require, extreme precision, which then frees up human workers to, focus on more specialized roles.
So it's not necessarily robots taking over, but more about robots and humans
Working together.
working together.
Exactly.
Right.
The team, yeah. And you look
Right.
at the automotive industry, for example. Robots are now used to assemble cars with incredible precision, but human workers are still needed to oversee the process, ensure quality control, and handle those tasks that require, more complex problem solving.
Yeah, and then we're also seeing like AI and the Internet of Things being integrated into manufacturing as well.
Yeah.
So how are those technologies kind of impacting things?
Yeah. Well, AI is really becoming the brains of the smart factory.
Oh.
So it can analyze massive amounts of data from sensors and machines to help optimize those processes and, predict maintenance needs and even identify potential problems before they even occur.
So it's kind of like a digital crystal ball for the factory.
Yeah, exactly. It's about, being proactive and keeping things running smoothly.
That's wild. But okay, so we have all these options,
Right.
3D printing, robotics, AI. Like, how do companies even begin to decide which
Yeah.
manufacturing process is right for a given product?
Yeah, it's a great question, and it's definitely not one size fits all, I imagine.
Material compatibility is key. You wouldn't use the same process to mold a piece of plastic as you would to forge a high-strength alloy, for example.
Right, right.
And the design complexity also plays a role. Intricate designs might require multi-axis machining or additive manufacturing, whereas simpler parts can be mass-produced with more traditional methods.
So you got to think about the material,
Yeah.
you got to think about the design, and then obviously how many you need to make.
Exactly. The production volume is a huge factor as well.
It's like this big puzzle where all the pieces have to fit.
It is. It is. And we also, can't forget about sustainability, which is becoming increasingly important in manufacturing.
Yes, definitely a hot topic these days.
Absolutely.
Yeah.
Companies are really striving to be more eco-friendly, minimizing waste, using renewable energy sources,
Right.
and embracing those circular economy principles where materials are reused and recycled.
Yeah, it's good to see that that's becoming, less of a trend and more of just like the standard.
Right, it's a necessity.
It's not just a nice to have anymore. It's something that, consumers are demanding, and it makes good business sense as well.
So we've talked a lot about, the technology, the processes, but what about the people?
Right.
Where do humans fit into all of this?
Yeah, well, the human element is still essential. Machines can handle certain tasks, but it's the skilled workers who are driving innovation, operating and maintaining these complex systems, and ensuring quality control at the end of the day.
So it's really about finding that balance between human expertise and all these technological advancements.
Absolutely, finding that synergy,
Yeah.
And that means focusing on training and education to prepare the workforce for the demands of this, rapidly evolving field.
Okay, so let's get into some specifics now. How do traditional manufacturing methods actually stack up against these advanced processes in terms of efficiency and waste reduction?
Right. Well, if you think about traditional methods like machining, you're often cutting away material to shape a part, so you end up with a lot of waste.
You're losing material.
You're losing material, exactly. But 3D printing, on the other hand, is additive. So you're only using the material that you need. It's a much cleaner and more efficient process.
And then what about things like productivity and cost savings?
Right. Well, these advanced technologies, they do require an initial investment, but they often pay off in the long run.
Okay.
Increased automation and robotics can lead to higher productivity, lower labor costs and shorter lead times. So it can really make companies more competitive.
So it's really about kind of thinking long term,
Exactly. Investing in the future of manufacturing.
future of making things. So, we talked about digital twins earlier, and I'm still kind of trying to wrap my head around that whole concept.
Yeah, it's a really fascinating idea. It's
Yeah.
essentially like having an X-ray vision into the inner workings of a product.
Oh, wow.
Or even an entire factory. So imagine having a virtual replica of a machine that updates in real time, showing you exactly what's happening inside.
So it's more than just like a 3D model, you're saying. It's like, yeah.
It's a living, breathing representation of the real thing. Yeah. And sensors on the physical object are constantly feeding data into the digital twin.
Okay.
So it's constantly updating its status.
You can actually see,
You can see how it's performing.
I think its health almost.
Exactly. Its
Wow.
health, its performance, and even its potential future.
You mentioned predicting problems. Like, how would that work, like in a real world scenario?
Sure. So let's say you have a wind turbine out in the field, right?
Okay.
By creating a digital twin of that turbine, you can actually monitor its performance remotely
From anywhere.
exactly. And you're tracking things like vibration, temperature, wind speed.
Yeah.
And if the data shows, unusual vibrations, it could indicate that a blade is out of balance. And that allows you to do preventative maintenance before you have a catastrophic failure.
That's incredible.
Yeah, it's really powerful stuff.
It's like a virtual mechanic.
It is, and it goes beyond just monitoring. You can use digital twins to simulate different scenarios.
Yeah.
So let's say you want to test how design changes to an airplane wing would affect its aerodynamics. You can do that all within the virtual world
Oh, wow.
before you ever build a physical prototype.
So you're basically eliminating risk,
Exactly.
at least in the design phase.
Yeah, it's a risk-free testing ground for innovation.
I like that.
And as these digital twins become more sophisticated and interconnected, they really have the potential to revolutionize not just individual products, but entire manufacturing ecosystems.
So we're talking like smart factories.
Smart factories, machines predicting their own maintenance needs, being able to test new ideas virtually before we actually commit to physical production. It's a really exciting time.
It is. It is. And it makes you think about like the workforce and the skills that people are going to need,
Right.
in this new era of manufacturing.
Absolutely. And it's no longer enough to simply operate a machine. Workers need to be comfortable with technology. They need to understand data analysis and be able to adapt to new systems quickly.
So it's less about manual labor and more about,
It's about critical thinking, problem solving, being able to analyze information and make decisions.
yeah, it was like a shift towards, more technical roles.
Yeah. And we also need people who can bridge the gap between the digital and physical worlds. So those who can translate the insights from the data into real world actions.
Yeah, you need someone who can connect those dots.
Exactly.
Because it's one thing to have all this data, But
You have to know what to do with it.
exactly, and that's what it comes down to.
Yeah, and the pace of innovation is only accelerating. So the ability to learn new skills and embrace change, that's going to be essential for success.
It's like a constant learning curve now.
It is. It is.
So we've talked a lot about the potential, the exciting things, but what about the challenges?
Right.
Are there any concerns surrounding, this whole technological revolution in manufacturing?
Well, one major concern is the impact on employment as automation increases. There's a fear that jobs will be displaced.
Where robots are taking over.
Right. That's the classic fear, but it's not quite that simple. While some routine tasks will definitely be automated, new jobs will emerge in areas like data analysis, software development, cybersecurity.
So it's not so much that jobs are going away, it's more like,
It's a skills gap
okay,
more than a jobs gap. So we need to invest in education and training programs to make sure that the workforce is prepared for this shift.
yeah, equip people with the skills they need to succeed.
Exactly. And another concern is cybersecurity. As factories become more reliant on interconnected systems, they become more vulnerable to attacks.
That makes sense.
So companies need to prioritize robust security measures to protect their data and their infrastructure.
It's almost like a new kind of risk that companies have to think about.
It is. It's a new landscape. And, it's not just about developing new technologies. It's about using them responsibly and ethically.
Right. It's got to benefit society as a whole.
Absolutely.
Well, this has been a really interesting discussion.
Yeah,
We've gone from the very basic fundamentals of material science all the way to like the cutting edge.
the future of manufacturing.
Yeah, and it's clear that this field is going to play a huge role in shaping the future.
Oh, absolutely. It's a really exciting time to be involved in this industry.
It's amazing to think about how far we've come from, blacksmiths and simple tools
Right.
to now we're talking about manipulating materials at the atomic level and creating things that were just pure science fiction a few decades ago.
Yeah, the pace of innovation is incredible.
It is.
And it's not just happening in research labs anymore. These advancements are becoming more accessible
Yeah.
to businesses of all sizes.
So it's not just the big companies anymore.
Exactly. It's really becoming democratized.
Right. Okay.
Tools like 3D printers, collaborative robots are becoming more affordable. So startups and small businesses can really leverage this technology.
That's exciting because that opens up a world of possibilities,
It does.
for entrepreneurs and inventors.
Absolutely. And what's really cool about this field is that it's constantly evolving.
Right.
What's cutting edge today is going to be commonplace tomorrow.
So if you had to predict what the next big breakthrough would
Oh,
be.
that's a tough one.
Yeah.
But I think we're going to see a convergence of nanotechnology, AI, and bio-inspired design.
Okay.
So imagine creating materials that mimic the properties of living organisms,
Oh, wow.
like self-healing materials or materials that can adapt to their environment.
It sounds like we're talking about like superhero stuff now.
Yeah, it kind of does, right?
Yeah.
But it's not as far-fetched as you might think.
Really?
We're already seeing self-healing materials being used in aerospace and automotive application.
That's wild. So what about the factories in the future then?
Right.
How are these advancements going to change the way we produce things?
Well, I think we're going to see a shift towards hyper-personalized manufacturing.
Okay.
So imagine factories that can produce custom-designed products on demand,
Wow.
tailored to each individual customer's needs.
So instead of mass production, it's more like mass customization.
Exactly.
That's a really interesting concept.
Yeah, and with 3D printing and robotics, this level of customization is becoming, increasingly feasible.
Well, this has been an incredible deep dive.
It has.
We've covered so much ground from the fundamentals of material science to the really cutting-edge advancements shaping the future of manufacturing. And it's clear that this field is going to play a huge role in, all of our lives.
It's an exciting time to be a part of this industry.
It is. And if you're as fascinated by this topic as we are, we encourage you to check out our website for links to all the sources we used in this deep dive.
And most importantly, stay curious.
Yes,
The world of materials and manufacturing is full of endless possibilities.
it really is.
And who knows, maybe you'll be the one to make the next groundbreaking discovery.
That's a great note to end on. Thanks for joining us on this deep dive into the future of making things.